Given that p of x is equal to this quartic and 1 plus 2i is a root, find the values of a and b. So first of all, given that 1 plus 2i is a root, that means that p of 1 plus 2i is equal to 0. That's the definition of a root. So that means that 1 plus 2i to the power of 4 minus 2 times 1 plus 2i to the power of 3 minus 1 plus 2i squared plus 1 plus 2i times a plus b has to be equal to 0. And that's a pretty long and complicated equation to be solving without a calculator specifically. So can we try and do this another way? Because we don't really want to have to use the binomial expansion on these various times. So can we find another way to do it? Okay, so let's park that for a second. We'll come back if we need to. Given that 1 plus 2i is a root, by the conjugate root theorem, 1 minus 2i is also a root. So that means that p of x can be written as x minus 1 plus 2i, x minus 1 minus 2i, times by, and because this is a quartic, we need 2 more linear factors, which means this is a quadratic. So x squared plus mx plus n, using letters that we're not already using a and b here. Expanding this gives me x squared. I'm going to get minus 1x, so minus 2x, and then minus 2ix plus 2ix, so that's going to cancel. So this has got minus 2x's. And then my constant term within this bit is going to be 1 plus 2i times 1 minus 2i. 1 times 1 is 1. 2i times 2i is minus 4i squared. That becomes plus 4. So 1 plus 4 is plus 5. Now, our normal trick at this stage is to think, well, how do we get the b, the constant? It's 5 times n. We can't do that here because we don't know what b is. So we're going to go the other way around. We've already got the x to the 4, but can we work out the x cubed? Well, how could we get x cubed? So x cubed, the only way we can get x cubes would be x squared times by x, or x squared times by x. Mark those differently. So at the moment, we've got minus 2x squareds, and we need minus 2x cubes, and we need minus 2x cubes. That means m is going to have to be 0. Now that we know that n is equal to 0, we can go a bit further and we can think about how many x squareds do we have? How do we get x squared? Well, the x squared either comes from 5 times x squared, or minus 2x times 0x, or x squared times by n. So at the moment, we've got 5x squareds plus 0x squareds, so 5x squareds, and we need minus x squared. So that means this one's going to have to be minus 6. 5x squareds minus 6x squareds gives me minus x squared. So this means, putting that together, we've got x squared minus 2x plus 5 times x squared minus 6. Now that I've got that second quadratic, I know I can write this as x squared minus 2x plus 5 times x minus root 6 times by x plus root 6. Because this is a difference of 2 squares, that's fairly easy to factorize, even though these are surd values. I can then find the remaining roots. The roots are 1 plus 2i, 1 minus 2i, root 6 and minus root 6. But I haven't quite answered the question because I was actually asked to find a and b, and I haven't actually found a and b yet. I found the roots, which was the second part. So how am I going to find a and b? Well, I'm going to expand this. Expanding this out is going to give me a and b. Could do that via the grid method or expanding out. All I'm really interested in is the linear and the constant term. So this bit here implies that b is the easier one. The constant term is 5 times minus 6, so b is minus 30. And a, my x terms, well, how can I get x terms? The only way I can get x's out of this is multiplying those two together. So a is going to be equal to minus 2 times minus 6, which is 12. So a is 12, b is minus 30, and my 4 roots are here.